Hello, today our group will be discussing about ionic bonds. We'll first start with the introduction where we show the basic ideas regarding this topic and then later moving on into more complex concepts. So let's start. What is an ionic bond? It is a type of linkage formed from the electrostatic attraction between oppositely charged ions in a chemical compound. This when a positively charged ion forms a bond with a negatively charged ion, and one atom donates electrons to the other. This bond forms between a metal and a non-metal element. How are ionic bonds formed? This bond forms when the valence or outermost electrons of one atom are transferred permanently to another atom. The atom that loses the electrons becomes a positively charged ion or a cation, while the one that gains them becomes a negatively charged ion or an anion. With the two ions having opposite charges, positive and negative, they form an electrostatic attraction which makes the bond between the two ions, turning them into an ionic compound. Here we have an example between sodium and chlorine. Both elements have neutral charges before the electron transfer, since they both have an equal number of protons and electrons. As you can see, sodium has 11 protons and 11 electrons, and chlorine has 17 protons and 17 electrons. Now, after the electron transfer, we can see that sodium has lost an electron. So, since it now has more protons, it will have a positive charge, so it will now become a cation. Chlorine, on the other hand, has gained an electron. Since there are more electrons than protons, it will now have a negative charge, so it will now become an anion. And those are the basic concepts regarding this topic. There are more subtopics to be discussed. This includes electronegativity in ionic bonds, relation of the stability of noble gases to their electron configuration, the Auckland rule, and the Lewis dot structure.
Electronegativity of ionic bonds. Electronegativity. Electronegativity is a measure of how strongly an atom pulls a shared electron pair towards it. The table below shows the electronegativities of a number of elements. For example, hydrogen has an electronegativity of 2.1, sodium has 0.9, magnesium has 1.2, and calcium has 1. The greater the electronegativity of an element, the stronger its attractive pull on electrons. For example, in this molecule of hydrogen bromine, the electronegativity of bromine is 2.8, which is higher than that of hydrogen, which is only 2.1. And so the shared electrons will spend more of their time closer to bromine atom. Bromine will have a slightly negative charge, and hydrogen will have a slightly positive charge. In a molecule like hydrogen, where electronegativities of the atom in the molecule are the same, both atoms have a neutral charge. Three basic ways to pair two atoms to bond them together. A. Two atoms with the same electronegativity, either both high or both low. This will cause the electrons that are shared in the bond to be evenly shared between the atoms. When atoms share electrons evenly between each other, the bond formed is called a nonpolar covalent bond. Next. Number 2. One atom with a somewhat higher electronegativity than the other. This will cause electrons to be shared unevenly, such that shared electrons will spend more time on average closer to the atom that has a slightly higher electronegativity. When atoms share electrons unevenly, the bond formed is called a polar covalent bond. Next, one atom's electronegativity is much higher than the other atom. In extreme cases, the electron in the bond spends so much time closer to the atom with high electronegativity that the shared electrons are considered to be transferred to that atom. The sharing is so uneven that one atom basically takes one or more electron from the other atom. When the electrons being shared are so unevenly distributed between the atoms, the bond that is formed is called an ionic bond. Nonpolar and polar covalent bonds. Electronegativity can be used to explain the differences between two types of covalent bonds. Nonpolar covalent bonds occur between two identical nonmetal atoms, for example H2, Cl2, and O2. Because the two atoms have the same electronegativity, the electron pair in the covalent bond is shared equally between them. However, if two different nonmetal atoms bond, then the shared electron pair will be pulled more strongly by the atom with the highest electronegativity. As a result, a polar covalent bond is formed where one atom will have a slightly negative charge and the other a slightly positive charge. This is represented using this symbol, which is slightly positive, and this, which is slightly negative. So in a molecule such as hydrogen chloride, hydrogen is slightly positive and chlorine is slightly negative. And that is all for the electronegativity of ionic bonds. Thank you.
The relation of the stability of noble gases to their electron configuration. Noble gases have a full outer electron shell, which makes these elements non-reactive. Noble gases, also called inert gases, belong to the group 18 of the periodic table. So these gases are neon, helium, argon, krypton, xenon, and radon. This section focuses on the electron configuration of these noble gases. So they do not need to gain, lose, or share electrons to achieve a fully fulfilled valence shell. Therefore, they are unreactive and will not react to form compounds. So as we know, to form compounds, a compound is formed when two or more different type of atoms are chemically combined. The number of valence electrons dictates the chemical properties of their elements. Therefore, in the chemical reaction, electrons lose, gain, or share between atoms. For example, to form sodium chloride, the sodium loses an electron to form sodium ion, while the chlorine gain an electron to form a chloride ion. In the formation of water molecules, they do not transfer but rather share electrons between oxygen and hydrogen. After forming bonds, atoms achieve a fully filled valence shell, just like the noble gases. The distribution of electrons in respective orbits of the noble gases is called noble gas configuration. The basis of any chemical reaction is due to their impulsive behavior of achieving a complete electronic configuration and achieving a level of stability. Chemicals reacted with one another to form the configuration of the nearest noble gas. Valence electrons are placed in the outermost orbital of an atom. These electrons form molecules when they combine with other atoms. Because inert gases have 2 or 8 electrons in the outermost orbital, so their valency is 0. Pseudo-noble gas configuration. So some elements have fully filled valence orbits, however their chemical properties differ from the group 0 elements. Noble gases have extremely low reactivity because of the fact that the outer shell of electrons is completely filled. So these non-metallic gases from the periodic table, on the other hand, have very low melting and boiling points, making them useful as coolants in refrigerators.
The octet rule. Things to remember in octet rule. Octet rule says atoms with 8 electrons in their outer shell are stable. Octet rule is a general rule or a simple chemical rule of thumb. In octet rule, atoms tend to join in such a way that of their valence shells has 8 electrons, resulting in the same electron configuration as a noble gas. The octet rule predicts how atoms will form chemical bonds to make molecules. The rule holds true to the main group of elements, such as carbon, nitrogen, oxygen, and fluorine, as well as metals like sodium and magnesium. In simple words, molecules or ions are most stable in their constituent atoms. Outer electron shells contain 8 electrons. Noble gases is a group of elements were discovered at the end of the 18th century. They were unreactive, so they were called noble gases. Later, they were called inert gases as they did not react and it sounded more scientific. Now, it is called noble again because they do react under extreme conditions. Atoms with a full outer shell of electrons are very stable. The octet rule is extensively used in drawing Lewis structure. Elements with 8 electrons in their outer shell is called octet. Octet rule is based on how atoms behave in the real world. Exceptions or limitation. DeWitt rule, like hydrogen, helium, and lithium, are stable with 2 electrons in their outer shell. Transition elements, 18 electron rule, which is stable with 18 electrons in their outer shell. How can atoms get a full outer shell? By transferring, which is gaining and losing electrons, and by sharing electrons, as the image shows.
Good day everyone. As we begin with our topic, which is the Lewis dot structure, let us define first some words that are related to our topic. What is Lewis structure? The Lewis structure is a very simplified representation of the valence shell electrons in a molecule. It is used to show how the electrons are arranged around individual atoms in a molecule. The valence shell is the outermost shell of an atom containing valence electrons. Valence electrons are the electrons that are located in the outermost electron shell of an element. Here is an example of valence shell and valence electron. The red circles represent the neutron, the green circles represent the proton, and the blue circles represent the electron. The outermost orbit is the valence shell, and the electrons that are located in the valence shell are called valence electrons. Now that we understand what a valence shell is and what valence electron is, let's now proceed to finding valence electron of an element. To find the valence electron of an element, use the group numbers in periodic table of elements to determine the number of valence electrons. The one place of the group number is the number of valence electrons in an atom of these elements. In other words, group 1, 1 valence electron, group 2, 2 valence electron, group 3, 3 valence electron, group 4, 2 to 4 valence electron, group 5, 2 to 5 valence electron, group 6, 2 to 6 valence electron, group 7, 2 to 7 valence electron, group 8, 2 or 3 valence electron, group 9, 2 or 3 valence electron, group 10, 2 or 3 valence electrons, group 11, 1 or 2 valence electrons, group 12, 2 valence electrons, group 13, 3 valence electrons, group 14, 4 valence electrons, group 15, 5 valence electrons, group 16, 6 valence electrons, group 17, 7 valence electrons, group 18, 8 valence electrons except for helium, which has 2 valence electrons. So all elements in group 1, the periodic table of elements from H hydrogen to Fr francium have 1 valence electron. Group 2, Be beryllium to Ra radium have 2 valence electrons, and so on and so forth up to group 18, or the noble gases, He helium to Og organisms, which have 8 valence electrons except helium, which has 2 valence electrons. Example: since carbon is in group 14, we can say that carbon has 4 valence electrons, and neon is a noble gas and in group 18, so neon has 8 valence electrons. Now that we know how to find the valence electron, let's now proceed to the Lewis-Dot structure of an ionic compound. So if we look at that periodic table of elements, the gray colored elements are metals, the blue colored elements are metalloids, and the yellow colored elements are non-metals. We can now determine which elements are metals and non-metals. So now let's find out how to draw the Lewis structure for an ionic compound using ionic bonding. Let's use sodium chloride, NaCl, as an example. Sodium chloride consists of 2 elements, which are sodium Na, a metal element, and chlorine Cl, a non-metal. If Na is in group 1, then it has 1 valence electron, and Cl is in group 17, so chlorine has 7 valence electron. If we can see, that is the atomic structure of sodium and chlorine. The first shell of sodium has 2 electrons, the second shell has 8 electrons, and the third and last shell, or the valence shell, has 1 electron, which is the valence electron. While in chlorine, its first shell has 2 electrons, its second shell has 8 electrons, and its valence shell has 7 valence electrons. Because an ionic bond is the result of electrovalence, or the transfer of electron from metal to non-metal in order to obtain a full valence shell, or the most stable electron configuration, we will do the ionic bonding to obtain that stable electron configuration like the noble gases. We have said that in ionic bonding, the metal will transfer its valence electron to a non-metal. So the 1 valence electron of sodium Na will transfer to chlorine Cl. So the chlorine now has 8 valence electrons, and it is now very stable like noble gases. Sodium loses its valence electron, and now it has no valence electron, but the shell underneath it has 8 electrons, so it's now stable as well. Because sodium loses electrons and the electrons are negative, the sodium becomes positive, called a cation. When chlorine gains an electron, it's become negative and is referred to as an anion. By convention, we should put a bracket around the negative ion, but sometimes We can also see a bracket around the positive ion as well. And that's what makes the Lewis structure for an ionic compound. Thank you.